Hi everyone, my name is Tong Zhang from IVRL EPFL. Today, I'm happy to be here to present how does AI technology contribute to digitalize comics. I still remember that when I was a kid, reading comic books was one of my favorite things. When I grew up, I moved several times and those books were also missing. But now, digitalization gives us another opportunity to read those books. With the increasing growth of digital devices in the world, digitalizing comics books and putting them on different devices is becoming more and more important. Nowadays, we can access different content on our mobile easily. When you watch a video online, the content provider will put different resolution videos with different heights and rates ratio to fit different devices. However, we cannot ask the comics writers to draw several versions of comics. As the size of different devices such as phones, tablets, and laptops changes a lot, it makes comics digitalization quite challenging. For example, how can we adjust an image from a 9-inch tablet to a 4-inch mobile? Let's simply introduce how we resize image in general. Images contains many pixels. You can think of every pixel as a block and their coordinates uniformly distributed from 0 to 1. If we want to resize the image, we have to first calculate the pixel coordinates. For example, if we want to downsample an image to half of its size, we first calculate the new coordinates based on the number of pixels. Then, we will use the correlation of new coordinates and old coordinates to find the coefficients. Finally, we can calculate the pixel color by weighted sum of surrounding pixel on the old coordinates. Let's see the results of simply resizing. When the size gets smaller than a ratio, the words will be hard to read and even the details of the main character is hard to capture. So, can we do it better? The answer is yes. We can naturally come up with an idea that keeps the important information change as less as possible, such as conversation and main character, while reducing the ratio of less important parts as the image we displayed. However, it seems easy for a human to decide which part is more important. It is super challenging for a computer to do so. Different from real images, the style of comics are decided by the writers. They are too diverse, such that the model cannot find a general rule across all the comics panel. We can observe that the state-of-the-art AI model is able to generate visually plausible images, but it totally fails to generate images that contain reasonable semantic objects and conversation. Therefore, in order to better represent the image with different sizes without changing the semantic meaning, we need to teach the computer not only to understand comic scene, but also know more about humans. First, the model needs to understand different semantic objects on every panel. But we cannot keep the size of every object in the panel, so the model needs to know the region that attracts human attention most. We call such regions as silent regions. Therefore, the model is trained to capture the most silent regions so that the model can decide which part is more important for human. However, sometimes small objects are not visually silent, but relate to the story. They are usually ignored by vision-based AI model. As a result, we need a language model to understand the story and associate the words with objects. Combining those three parts, the model will be able to resize the image according to different objects based on their importance, instead of resizing all the pixels uniformly. Let's say some comparison of the simple resizing and the trained model. Here is the resizing image. The conversation and main character are distorted. And the learned model could keep the geometry shape of the image region much better than resizing. Except for resizing, the trained model could also edit the image. For example, remove some objects from the image. Lastly, the model can also extend the content of image by itself. It can keep the image content while enlarging the image based on its own understanding. That's all my presentation. Thanks for your attention.